Today, we're going to talk about hearing loss, but we're going to break it down and really demystify the two main ways it happens. You can think of it as a journey of sound, and what happens when that journey gets interrupted in two totally different ways. All right, let's jump right in. So, first off, what does it actually mean to have hearing loss? It seems like a simple question, right? But the answer is pretty specific. It's not just about needing to crank up the TV volume. There's a real medical line in the sand. And here it is. That line is 20 decibels. A person is officially considered to have hearing loss if they can't hear as well as someone who has a hearing threshold or 20 decibels or better. You can think of that as the starting point for what's considered normal hearing. Anything above that number, and you're starting to get into the zone of hearing loss. Now, way at the other end of that spectrum, you have deafness. And the definition here is simple but profound. It's the total inability to appreciate or hear sound. So it's super important to remember that hearing loss isn't just one single thing, it's a whole range, and deafness is at the very far end of it. Okay, so to really get a handle on the two types of hearing loss, we're going to follow the path a sound wave takes. I'm talking from the moment it leaves a source, travels through the air, and makes that incredible journey all the way to your brain. It's a fascinating process, and where that process gets interrupted, well, that changes everything. So our first stop is what happens when there's a problem with conduction. I want you to imagine that path sound takes as a road. In this first type of hearing loss, something is literally blocking that road. This is what we call conductive deafness. And the name says it all, right? The issue is in the external or the middle ear. Those are the parts of the ear whose only job is to conduct the sound waves inward. The sound itself is perfectly fine. It just can't get where it needs to go. And this is why that blocked road analogy is so perfect. The sound waves are physically stopped, or at least muffled, before they can even get to the inner ear, which is where all the complex processing happens. It's basically a mechanical problem. So what kind of things can cause these blockages? Well, it could be something as simple as a buildup of earwax or a middle ear infection. That's otitis media. Or maybe a perforated eardrum. In every one of these cases, there's a physical barrier in the external or middle ear that's getting in the way of the sound. But here's what's really fascinating about this type. Conductive deafness almost never leads to total deafness. And you might be wondering why. Well, it's because even if your ear canal is blocked, sound vibrations can take a detour. They can travel right through the bones in your skull directly to the inner ear. It's like a built-in backup route for sound. Okay, so if the first problem is a blocked road, what's the second type? This one is a problem with sensation. The road is clear this time. There's no blockage. Instead, I want you to think of it like a broken phone line. The call gets through, but the message itself is scrambled or just gone. And this is what we call sensorineural deafness. So here, the issue isn't about getting the sound to the inner ear. It's about what happens once it gets there. The problem is deep inside, either with the tiny sensory cells in the inner ear or along the nerve pathway that's supposed to carry the signal to the brain. That broken phone line analogy just clicks, doesn't it? The sound waves arrive just fine, but the delicate little mechanisms that are supposed to turn those physical vibrations into electrical signals for the brain, they're damaged. Or the nerve itself is faulty. The message just gets lost in translation. And as you can imagine, the causes here are totally different. We're not talking about simple blockages anymore. We're talking about actual damage. Things like being around loud industrial noise for years and years, which can destroy those delicate hair cells. Or certain drugs that are unfortunately toxic to the ear. Even a tumor pressing on the auditory nerve can cause this kind of hearing loss. And here's the crucial difference. Unlike conductive deafness, this type often leads to severe or even complete hearing loss. Why? Because when those sensory cells or the nerve pathway is damaged, there's no backup route. There's no secret passage. That phone line is well and truly down. So, there we have it. Two very different journeys for sound, leading to two very different kinds of problems. Let's just put them side by side for a second to make this super clear. This table really sums it all up, doesn't it? With conductive deafness, the problem's in the external or middle ear. The core issue is getting the sound conducted, and it's usually not a complete loss of hearing. Then you have sensorineural. The problem is in the inner ear or the nerve. The core issue is the sensation or processing of sound, and yeah, it's often severe or even complete. It's the blocked road versus the broken line. Okay, so you might be thinking, this is interesting, but why does this distinction actually matter so much? Well, it's way more than just a medical fun fact. It's everything when it comes to diagnosis and ultimately how we help people reconnect with the world of sound. And honestly, this is the main takeaway. Figuring out if the problem is conductive or sensorineural is the absolute most critical first step. Because think about it, you can't fix a damaged nerve with eardrops, and you don't need a complex implant to remove a bit of earwax. Knowing the cause points directly to the right treatment. Our ability to hear is one of the most fundamental ways we connect to the world around us and to each other. It's a connection that's so easy to take for granted. So I'll just leave you with this to chew on. What sound, if you couldn't hear it anymore, would you miss the most?